Humanity has lived for thousands of years on Earth with the same quiet question whispered into the night. Is there anyone else out there? In the almost eerie silence of the cosmos, our small blue planet seems like a lonely spark adrift among billions of celestial bodies. Perhaps that is why the desire to search for life beyond Earth has never faded. Great research efforts and daring explorations have brought us many clues, yet never quite enough to soothe our curiosity. Are we truly the only living beings in this vast universe? Or somewhere, across distant worlds, is another form of life quietly waiting to be discovered? Now, our hope has turned toward a place that feels so familiar and yet remains full of mystery, the Moon's South Pole. In its permanent shadows and ancient ice may lie the answers to one of humanity's greatest secrets. Why has this region become so sought after? What discoveries at the lunar South Pole have rekindled our faith in the possibility of life? And are we standing at the threshold of a new era, one where life beyond Earth is no longer just a dream? And welcome back to the Sleepy Explorer, your quiet corner of the night where curiosity drifts in like a soft breeze, and wonder never needs to hurry. Now, don't worry, this isn't the kind of space talk that keeps you awake with flashing lights outside your window. Think of it more like opening a quiet storybook at the edge of sleep, where science and myth wander together, with just enough mystery to make you smile before drifting off. Before we drift too far, I'd love to know, where in the world are you listening from tonight? Are you wrapped in a blanket, the glow of your screen the only light in the room? Or maybe lying back somewhere the night air carries the sound of crickets? Share your local time if you'd like. It always feels magical to see this sleepy little community shining like constellations scattered across the Earth, all under the same moon. And if this gentle voyage brings you a bit of calm, you're welcome to give it a like or subscribe, but only if it feels right for you. That way, this little ship of quiet wonder we're building together can keep finding new fellow travelers out in the digital night. Our journey into the truth begins now, in tonight's story, the Moon's South Pole, key to life beyond Earth. Imagine the night as a vast ocean, silent, endless, its surface sprinkled with distant lanterns. For as long as we've existed, humanity has floated on a small island in that ocean, gazing upward and wondering, is there anyone else sailing these waters? The question has lingered like a whisper, fragile but persistent, carried across centuries of stargazers, dreamers, and scientists. On quiet nights you may feel the same echo. Looking up you see stars that seem eternal, and yet they tell you nothing. The universe holds its secrets with a stillness so absolute it can feel almost eerie. Earth, our blue home, shines like a single speck of light, solitary among billions of celestial bodies. That sense of loneliness is what fuels our search. The silence does not make us stop asking, it only makes the asking more urgent. And so, humanity has kept listening. We built instruments sharper than our eyes, launched spacecraft farther than our feet could ever carry us, and traced the faint signatures of molecules and radiation across space. We've listened for radio signals, sifted through cosmic dust, and followed the trails of comets as if they might be carrying messages in ice. Yet, despite all these efforts, the question remains unanswered. No clear voice has ever whispered back. But recently, our gaze has turned to a place closer than the faraway stars. Not to the exoplanets hundreds of light years away, not to the frozen oceans of Europa or Enceladus, but to our own nearest companion, the Moon. So familiar, always present in our sky, and yet still holding mysteries in the folds of its surface. Specifically, it is the Moon's South Pole that has captured our imagination. Unlike the bright face we know so well, this region is marked by vast craters cast in eternal darkness. Because of the Moon's slight tilt, sunlight never touches their depths. Temperatures there plunge to extremes colder than Pluto, preserving ice for billions of years. Within these frozen shadows may lie records of the early solar system, trapped in silence, waiting to be read. And more than that, there may be something that connects directly to our oldest question. Are we alone? Could these ancient ices, shielded for eons, harbour clues not only to the Moon's history but to life itself? to the chemistry that could give rise to something alive, or perhaps to the fragile remains of life forms carried here long ago? This is why the South Pole has become a beacon of hope. Nations plan missions, scientists debate theories, and storytellers, like us tonight, lean in close, because perhaps, just perhaps, the answer humanity has sought for millennia is hiding there, in a place so near and yet so unreachable. The whisper from the moon's edge has grown louder, and if we listen carefully, in the quiet of the night, it almost feels like it's calling us closer. When we look at the moon, it feels almost too familiar. A neighbour that's always been there, quietly watching us from the same distance night after night. Its face hasn't changed for all of recorded history, the same seas and craters greeting every generation. Poets once called it a mirror of longing, scientists later mapped it with precision, and children still trace its glow from bedroom windows. Yet familiarity can be deceiving. The moon may feel like a simple, silent companion, but it has kept its secrets well. For centuries, humanity assumed it was nothing more than a dead rock, dry, airless, incapable of sheltering anything resembling life, and for most of its surface that assumption holds true. But the South Pole is different. There, in the darkness that never lifts, lies something we had long overlooked, a kind of natural archive. In those frozen depths, time slows. Molecules that would have been erased by sunlight or scattered by winds on Earth may still linger, preserved in delicate ice. To scientists, these shadows are like vaults, each crater a locked chest that could contain traces of the solar system's early chemistry, untouched for billions of years. But beyond the science, there's a more emotional pull. Something about those eternal shadows resonates with the human imagination. They feel like thresholds, places where light ends and mystery begins. To stand at the rim of such a crater, looking down into an abyss colder and darker than anywhere on Earth, is to feel both awe and unease. It's the kind of place where the silence feels almost alive, where you half expect to hear a whisper rising from below. That whisper, of course, is not a voice. It is the tug of possibility, the idea that beneath those shadows may lie a clue to one of humanity's greatest questions, whether life, in some form, could exist beyond our world. Even if no organism has ever stirred within that frozen soil, the chemistry preserved there might tell us whether the spark of life can ignite under conditions we once thought impossible. This is why so many missions are aimed at the lunar South Pole. It isn't just about exploration, or resources, or even national pride. It is about wonder. The same wonder that carried us to the Apollo landings now carries us back, not just to plant a flag, but to listen more carefully, to lean in closer to the silence, in case it has something to say. In that sense, the South Pole is more than a location on a map. It is a symbol of patience, of hope, and of our restless longing to know whether we are truly alone. Humanity has always searched for mirrors in the cosmos, places where we might glimpse ourselves reflected in some other form of life. Perhaps, just perhaps, those mirrors are waiting in the darkness of the moon's edge. If you close your eyes for a moment and imagine those craters, the thought alone feels like standing at the edge of a vast well. You peer down, but there is no bottom, only an endless night that has never seen sunrise. It is a darkness untouched, unbroken, almost sacred in its silence. And perhaps, hidden within it, lie fragments of stories older than Earth itself. For scientists, those stories could reveal how the early solar system brewed its ingredients, simple molecules colliding and rearranging, building the scaffolding of chemistry that, under the right conditions, might lead to life. For dreamers, those stories take another shape, a hope that somewhere in the frozen quiet, a trace of life has been sleeping, waiting to be found. And for all of us, even without instruments or missions, the South Pole has become a kind of lighthouse, a beacon that flickers, not with brightness, but with possibility. It reminds us that mystery is not always far away in some distant galaxy. Sometimes it is right above us, close enough to see with the naked eye, yet still out of reach. The moon has always been a companion in our night sky, constant and familiar, but its South Pole is something else, a reminder that even the most familiar companions can still surprise us, still whisper secrets we have not yet learned to hear. And so, beneath the hush of stars, we lean closer to those shadows, listening. What they may reveal could change not only how we see the moon, but how we see ourselves. Step closer, in your imagination, to the rim of a lunar crater at the South Pole. The sunlight grazes the edge of jagged cliffs, painting them in pale silver, but never once does it reach the floor below. Down there, the shadows are absolute, a darkness that has lasted not just for years or centuries, but for billions of years. These are the moon's permanent nightlands, places where dawn has never come. The reason is simple but profound. The moon tilts only slightly on its axis, just 1.5 degrees compared to Earth's generous lean. Because of that, sunlight never sinks deep into certain craters near the poles. Their walls are too steep, their orientation too sharp. So while the moon turns and the days and nights pass for the rest of its surface, the bottoms of these craters remain sealed in darkness. And what a darkness it island! In those pits, temperatures plunge lower than almost anywhere else in the solar system. -240 degrees Celsius, colder than Pluto, colder than the Kuiper Belt objects drifting at the edge of our star's light. At such extremes, molecules that would evaporate instantly elsewhere are frozen solid, held in place as if time itself has slowed to a halt. Think of them as natural freezers, unimaginably vast, preserving fragments of cosmic history. Within the frost may lie grains of water ice, perhaps mingled with traces of carbon compounds and volatile elements. To touch that ice would be to touch something unchanged since the earliest days of the solar system, a kind of archive written not in ink, but in frozen molecules. For us here on Earth, used to a world where everything moves and changes, this permanence feels alien. Our planet has weather, erosion, winds, oceans, and tectonic restlessness that erase the past again and again. But on the moon, especially in these frozen shadows, memory is kept. What fell there billions of years ago may still rest there, unchanged, silent witnesses to cosmic events long forgotten elsewhere. Standing at the edge of such a place, you might feel the strangeness of time itself. Above you, stars move, Earth spins, life flows, but below, in the crater's bottomless dark, nothing changes. It is as if two realities touch, one of ceaseless motion and one of endless stillness. It helps to imagine these craters as libraries of silence, not libraries with books and shelves, but vaults of matter, where every grain of ice and dust is a page waiting to be read. On Earth, the past is always rewritten. Rain dissolves, winds scatter, volcanoes bury, oceans recycle. But here, in the moon's eternal shadows, the record is unbroken. Time does not edit, it only preserves. Within these shadows, sunlight has not burned molecules into new shapes, radiation has not stripped them away, and warmth has not melted them into oblivion. What lies beneath is, in some sense, a memory of the solar system's childhood, chemistry preserved in amber, cold and silent. To scientists, it's like stumbling upon a diary written in the first language of creation. But it's not only history that the shadows hold. They may also keep the building blocks of possibility. Water ice, for example, fragile, crystalline, delicate, cannot last long on sunlit surfaces of the moon. It sublimates, drifting into space almost as soon as it's exposed. Yet here, in these natural freezers, it endures. Each particle of ice is more than frozen water, it is potential. Water means fuel, water means air, water means the raw material of life as we know it. And then, there are the whispers of more complex molecules, carbon compounds, organic precursors, volatile chemicals that may have rained down on the young moon from comets and asteroids. On Earth, such molecules danced in warm oceans, colliding and recombining until life sparked into being. On the moon, they may have simply slept, locked away in these lightless craters waiting for someone curious enough to look. To stand on the edge of such a place, to know that beneath your feet might be both a time capsule and a treasure chest, is to feel a paradox. These shadows are barren, lifeless, frozen beyond imagining. And yet, They may contain the closest thing we have to evidence that life could arise elsewhere. Not proof, not yet, but the fragile suggestion of a possibility. And so, the south pole of the moon has become more than just a frontier of geography. It is a frontier of hope. A place where the absence of sunlight has preserved the very ingredients that could one day answer humanity's oldest question. From afar, the moon's surface looks simple. Bright plains, familiar craters, a face we have known for all of human history. But as the light falls and shadows deepen, a second moon begins to appear. Not the shining companion of poets, but a world of silence where the cold is absolute and the dark has never broken. In those hidden hollows, time itself feels suspended. Every frozen particle is a fragment of memory, every untouched surface a reminder of just how long the universe has been keeping secrets. Above, the sun sweeps across the heavens, Earth spins through its seasons, and life moves forward without pause. Yet in the moon's south pole shadows, the past endures, waiting with extraordinary patience. This contrast is part of the allure. On the surface there is light, visibility, and the familiar emptiness of dust. But step just a little closer to the rim of shadow, and suddenly you are at the threshold of something different. A place where permanence wins over change, where molecules are not erased but protected, and where even the simplest drop of ice carries the weight of possibility. And possibility is what has drawn us here. Because somewhere in this frozen dark may lie more than just memory. It may hold water, locked away in crystal form, quietly shaping the future of how we explore and perhaps even live beyond Earth. Imagine standing at the edge of one of those eternal shadows, looking down into the blackness. You cannot see it, but beneath that darkness lies something precious. Ice. Fragile, ancient, and astonishingly resilient, it has survived for billions of years in places where sunlight never intrudes. To the human eye, the floor of such a crater may appear empty, just a dark canvas. But to science, it is a reservoir of frozen whispers. The idea that the moon might hold water was once thought almost impossible. For much of the 20th century, astronomers described it as utterly dry, a world baked clean by the sun and stripped bare by its lack of atmosphere. In school books, the moon was drawn as a desert of dust and stone, silent and lifeless. Yet hints began to surface, like faint ripples on an otherwise still pond. One of the first real clues came from a mission called Lunar Prospector, launched in 1998. Its instruments traced subtle signatures of hydrogen near the poles. Hydrogen alone did not guarantee water, but it was a tantalizing hint. Like footprints in snow, it suggested something might be there, even if unseen. The data revealed concentrations exactly where those permanent shadows lay, as if nature itself had pointed a finger toward the craters and said, "Look closer." And so we did. A decade later, India's Chandrayaan-1 mission carried an instrument called the Moon Mineralogy Mapper, built in collaboration with NASA. It confirmed what many had dared to hope. Spectral fingerprints of water molecules, bound in ice and scattered across the shadowed regions. It was not a lake or a river, but grains and patches, clinging stubbornly to the dark. For the first time, we could say with confidence, the moon is not entirely dry. That discovery rippled outward, reshaping how we saw our closest neighbour. Suddenly, the moon was no longer just a place of dust and memory. It was a place with resources, a place that might one day sustain explorers, and perhaps even settlers. It was as though the silence of the craters had spoken back, and its message was simple. There is water here. But water on the moon is not like water on Earth. There are no flowing rivers, no glaciers marching across valleys, no rain falling from clouds. Instead, the ice has accumulated through stranger, slower processes. Some of it likely came from comets and asteroids long ago, their collisions scattering fragments of ice that settled into the shadows. Some of it may have formed when solar wind, streams of protons from the sun, struck the lunar soil, reacting with oxygen in the minerals to create hydroxyl, then combining into tiny molecules of water. These molecules would hop across the surface, like restless travellers, until they found the safety of a permanent shadow, where cold locked them into stillness. The result is a patchwork of frozen traces, scattered and subtle, but undeniably present, a reminder that even in the harshest landscapes, persistence finds a way. After Chandrayaan, one whispered its discovery, other missions leaned closer to the shadows to listen. In 2009, NASA's Lunar Reconnaissance Orbiter, often called LRO, began circling the Moon, its instruments scanning every crater, every ridge, every shadow. One of its tools, a radar, was able to peer beneath the upper crust of regolith. What it saw was extraordinary. Reflections that behaved as if they were bouncing off not just rock, but ice. That same year, NASA conducted a bold experiment. A mission called Lunar deliberately sent a spent rocket stage crashing into a crater near the South Pole. The impact kicked up a plume of dust and vapor, which a trailing spacecraft immediately analyzed. Within that dusty spray, unmistakable signatures of water were found. It was as if the Moon, when struck, had exhaled, revealing its hidden breath of ice. Piece by piece, the picture grew clearer. The shadows were not merely dark holes in the ground, they were reservoirs. Not vast oceans, but delicate stores of frozen water, scattered like pearls in a bed of black velvet. Enough to matter, enough to shift our imagination of what the Moon could be. And what a strange kind of water at island. Unlike the flowing rivers we know on Earth, the lunar ice is more like frost sealed in a vault. Imagine a river caught mid-motion, its surface frozen solid not for a season but for eons. Every crystal has been locked in stillness since the earliest days of the solar system. If you could hold it in your hands, you would be touching a time capsule, a fragment of ancient history preserved with unearthly patience. Scientists sometimes describe these deposits as cold traps, places where molecules wander the Moon's surface until they stumble into a shadow too deep to escape. Once there, the temperature is so low they cannot leave, frozen into permanence. Over billions of years, these traps may have gathered not just water, but other volatile substances, carbon dioxide, ammonia, even faint traces of organic material. Like a collection of forgotten letters, sealed and waiting, each layer of ice could tell a story of cosmic delivery and quiet preservation. For explorers, the implications are profound. Where there is water, there is potential. Not just for sustaining life, but for fueling rockets, producing oxygen, and anchoring a human presence beyond Earth. The ice in those shadows may be as valuable as any treasure buried underground. And yet, its greatest value may not be practical at all. Its greatest value may be symbolic, proof that even in a place long assumed to be barren, nature has quietly stored away something vital. When you think about it, the presence of ice on the Moon feels almost like a contradiction. Here is a world without air, without rain, without clouds, a place bathed in raw sunlight and cosmic rays, and yet, in the corners where light has never touched, water has found refuge. It lingers there in silence, patient and enduring, like a secret kept for billions of years. For humanity, this discovery is more than a scientific triumph. It is a reminder that life's essentials can appear in the unlikeliest of places. Water is not only the substance we drink or the element we use to grow food, it is the universal symbol of potential. On Earth, wherever water flows, life tends to follow. On the Moon, water whispers of possibilities yet unrealized. Think of it as a bridge. On one side we have the practical ice as fuel, ice as air, ice as the foundation of future lunar settlements. On the other side, we have the poetic ice as evidence that the cosmos is not as barren as it first appears, that even in the stillest shadows something essential can endure. Between those two sides lies the real treasure, the chance to expand both our reach and our imagination. And perhaps that is why the discovery of water in the Moon's South Pole shadows resonates so deeply. It does not just change how we plan missions, or how we might one day live beyond Earth. It changes how we feel when we look up at the Moon. No longer just a cold neighbour, it becomes a keeper of something precious, not life itself, but the conditions that hint at it, the ingredients that whisper it could be possible. As we lean into that whisper, we begin to understand why these frozen shadows have captured so much attention. They are not simply craters filled with darkness. They are mirrors, reflecting both our scientific drive and our timeless yearning to know whether life might exist beyond Earth. And so, with the knowledge that water truly lies in the moon's shadows, we can begin to ask a larger question. If the resource is there, if the building blocks are present, what does that mean for us, for science, for exploration, and for the possibility of finding life itself? If there is one substance that binds together all the stories of life, it is water. From the oceans that cradled the first cells on Earth, to the rivers that carve valleys, to the clouds that circle endlessly above us, water is the quiet thread that runs through every chapter of our planet's history. Without it, there is no green on the hillsides, no breath in our lungs, no blue world for the moon to orbit. So when we find even the faintest trace of water beyond Earth, our hearts leap. It is not only about molecules and chemistry, it is about possibility. The discovery of ice in the moon's South Pole shadows struck such a deep chord because water is more than a resource. It is a promise. On the most practical level, lunar ice could change everything about exploration. Imagine the logistics of carrying water all the way from Earth, heavy, costly, limiting. Now imagine being able to harvest it from the moon itself. Astronauts could drink it, plants could grow with it, and through the magic of chemistry, it could be split into oxygen and hydrogen. One breathes, the other fuels. Suddenly, the moon is not just a destination but a stepping stone, a place where rockets can refuel before venturing farther into the solar system. The numbers tell a striking story. Even a modest supply of ice could reduce mission costs by unimaginable margins. A liter of water delivered from Earth to space can cost thousands of dollars. But if we can draw that liter from a shadowed crater, it becomes not just cheaper, but transformative. It means the moon could support a presence that is sustainable, not fleeting. Yet the importance of water is not only practical. There is also something profoundly human about it. Water is comfort. Water is life. Water is memory. The idea that it exists on the moon connects us more deeply to our closest neighbour. The same substance that laps against Earth's shores may be glinting in frozen grains, hidden in lunar shadows. That thought alone makes the moon feel less alien, more like kin. And beyond symbolism, there is science. To study lunar ice is to study history. Each frozen deposit is like a record of cosmic deliveries, comets, asteroids, solar winds. By analysing its layers, we may read the diary of how volatile compounds travelled through the solar system and how the ingredients for life were distributed across worlds. Lunar ice is both resource and archive, fuel for tomorrow and memory of yesterday. Picture, if you will, a small outpost at the rim of a crater. Its walls are curved like seashells, glinting softly in the sunlight that never quite touches the shadowed floor below. Around it, the surface stretches pale and silent, but within, life stirs, plants unfolding in hydroponic trays, explorers breathing air drawn not from tanks carried across the void, but from the very moon itself. This vision may sound like science fiction, yet the discovery of water ice is what begins to make it possible. With water harvested from the lunar shadows, astronauts could drink without rationing every drop brought from Earth. They could breathe oxygen split from H2O molecules. And with hydrogen extracted, rockets could be fueled for journeys far beyond the moon. Think of the South Pole as more than just a region. It could become a harbour, a refueling station on the shores of space, where ships pause before setting sail to Mars or even farther. Instead of treating the moon as a cold, dead rock, we might one day treat it as the first port of call in a solar system-wide voyage. The idea is not entirely new. For decades, planners and dreamers imagined lunar bases, but they were always constrained by one problem: supply. Every kilogram had to be hauled up Earth's gravity well, at tremendous cost. Water on the moon changes that equation. It means the moon could support itself, at least in part. It means permanence is possible. And permanence matters. To stand on the moon for a moment, as Apollo astronauts did, is breathtaking. But to stay, to live and work there requires roots. Water is the root system. It anchors us to the possibility of not just visiting, but belonging. And with belonging comes another transformation. The moon, once seen only as a symbol of distance and mystery, could become an extension of home, a place where human voices echo in domes, where instruments hum, and where, perhaps, green leaves unfurl under artificial light, all because of a few frozen grains preserved in the silence of shadows. When we speak of water, we are never only speaking of chemistry, we are speaking of a symbol, a reminder that life, in all its countless forms, always begins with something fluid, something that flows. To find water beyond Earth is to feel a sudden closeness to the cosmos, as if the universe itself is not quite as distant, not quite as indifferent as it sometimes seems. There is a quiet poetry in the thought that water may glisten on the moon, the same element that fills our oceans and streams, that falls softly as rain, that cradles the reflections of our skies, may also be locked in silence, waiting in craters that have never seen the dawn. It is as if Earth and Moon, long companions, have been sharing a secret all along, one that we are only now beginning to uncover. For scientists, these frozen deposits are archives of cosmic delivery, records of comets and asteroids that once seeded the inner solar system. For explorers, they are stepping stones toward permanence. But for dreamers, they are something more subtle, a reassurance that even in the coldest, darkest corners, the ingredients of life persist, that the universe may be less empty, less barren than our fears would suggest. And so, when we imagine dipping a hand into lunar ice, we imagine more than just fuel or oxygen. We imagine touching a thread that ties us to the origins of life, and perhaps to its future beyond Earth. In that frozen water lies a mirror, reflecting both our practical ambitions and our quiet longing to not be alone. The shadows of the moon's south pole hold water, and within that water they hold a promise that exploration is not just about distance, but about connection to our past, to our present, and maybe, one day, to other forms of life waiting somewhere in the stars. And if water is the promise, then what else might these shadows contain? Beyond ice, beyond simple molecules, what chemistry could be hiding in the dark chemistry that might blur the line between the non-living and the living? If water is the promise, then chemistry is the language in which that promise is written. Every drop of ice, every grain of frozen dust, carries within it the potential for words that have not yet been spoken, words spelled out in molecules, fragments of life's alphabet scattered across the dark. On Earth, we know this alphabet well. Hydrogen, carbon, oxygen, nitrogen, simple letters that, when arranged in the right sequence, become sugars, amino acids, and eventually the fabric of living cells. But what about the moon? Could its shadows, so silent and cold, hold fragments of that same language? Scientists think so. They believe that within the permanent darkness of the South Pole, volatile compounds have been preserved along with the water. Carbon dioxide, ammonia, methane, even faint traces of more complex organics, each delivered by comets, asteroids, or the steady drizzle of micrometeorites. Over time, these compounds may have collected like forgotten notes in a drawer, undisturbed for billions of years. And then there is another process, quieter but just as powerful, radiolysis. Imagine the constant wind of particles streaming from the sun, tiny messengers striking the lunar soil. Each proton that hits the surface has the potential to split molecules apart, to rearrange bonds, to create something new. Oxygen trapped in lunar minerals, when struck by solar protons, can combine into hydroxyl groups. Those groups, in turn, can link together to form water molecules. But radiolysis doesn't stop at water. It can also forge and fracture carbon compounds, nudging them into more complex structures. In Earth's laboratories, scientists have recreated similar reactions, watching as radiation transforms simple molecules into the precursors of organics. The moon's shadows, shielded from sunlight but not from cosmic particles, may have hosted such chemistry for eons, quietly assembling fragments of potential. Think of it like this. Every cosmic ray, every solar particle, is a stroke of chalk on an invisible blackboard. Over billions of years, those strokes accumulate into patterns, some meaningless scribbles, others perhaps the first sketches of a recipe. The craters at the moon's south pole may hold these chalkboards intact, waiting for us to lean closer and read what has been written. And if those writings contain not life itself, but its prelude, that would still be extraordinary, because in those frozen molecules, we would see proof that the universe is naturally inclined to experiment with the building blocks of life, not just on Earth, but wherever conditions allow. Picture those molecules lying in darkness for eons. They are not alive, not yet. They do not move or breathe, but they wait. Like seeds sealed in a vault, they endure in stillness, preserved by cold so absolute that change slows to nearly nothing. On Earth, seeds can remain dormant for centuries, awakening only when soil and rain arrive. In the moon's craters, these molecular seeds may have been waiting not for rain, but for curiosity for us to notice them, to lift them gently into the light and ask what stories they hold. The shadows of the South Pole are ideal guardians for such fragile cargo. Without sunlight, there is no heat to drive reactions into chaos. Without an atmosphere, there are no winds to scatter or oxidize. What falls into these craters, a flake of ice, a grain of organic dust, simply rests there, layered and compressed, like thin pages in an untouched book. Over time, these layers may have built up into a quiet archive of cosmic chemistry. Some of these molecules likely arrived on comets. Comets are rich in organics. We have seen it firsthand from missions like Rosetta, which revealed complex carbon-based compounds clinging to icy nuclei. Imagine one such comet grazing the moon billions of years ago, scattering fragments into the South Pole. In sunlight, those fragments would vanish. In darkness, they endure. Others may have been delivered by asteroids or even the fine drizzle of micrometeorites, each carrying traces of carbon and nitrogen. Together, across unimaginable spans of time, they might form a mosaic, scattered hints of the chemistry that, elsewhere, has given rise to life. The beauty lies in the patience of it all. On Earth, chemistry dances quickly, stirred by water and warmth. On the moon, chemistry sleeps, but it does not vanish. It is a kind of frozen rehearsal, a prelude played out in molecules rather than melodies, and if we learn to read it, we may find that even lifeless places have been quietly composing verses of the same universal song. The thought is humbling. In the deepest lunar shadows, on a world we long believed to be silent and barren, there may be fragments of a story that belongs to us all. Molecules without breath, without thought, but carrying within them the faint architecture of what could be. They are not alive, yet in their shapes we recognize the same letters that compose the sentences of every tree, every ocean, every heartbeat on Earth. Perhaps they are nothing more than frozen relics, chemistry without consequence. But perhaps, in some future where warmth and time conspire together, they could stir, shift, and arrange themselves into something more. Life, after all, begins not with grandeur, but with subtlety. A bond here, a chain there, a spark of stability in the midst of chaos. If that is the case, then these molecules are more than dust. They are bridges. Bridges between the lifeless and the living, between the silence of rock and the whisper of breath. To uncover them would be to uncover a thread of continuity, proof that the cosmos does not draw such a sharp line between alive and not alive as we sometimes imagine. And even if no such transition has ever happened on the moon, these chemical hints tell us something precious. The universe keeps scattering seeds. Seeds that may never sprout in some places, but that carry the potential all the same. Seeds that have already bloomed on Earth. Seeds that might bloom again elsewhere. Which leads us to another possibility that the moon's chemistry is not just a native creation, but a gift. A delivery from beyond. What if these seeds of organics did not originate here at all, but fell from the sky, carried by visitors far older than the craters themselves? Every seed needs a carrier. On Earth, seeds ride the wind, hitchhike on animal fur, or drift down rivers to find new soil. In the cosmos, the couriers are different, but the principle is the same. The universe, it seems, has its own gardeners, comets, asteroids, and meteorites, scattering fragments of chemistry from one world to the next. This is the essence of an idea called panspermia, the notion that the ingredients of life, or perhaps even life itself in its tiniest, most resilient forms, might travel between planets. To some, it sounds fantastical, yet in recent decades the evidence has piled up that these celestial messengers are not barren stones. They are rich with organic molecules, carrying the raw material of life across unimaginable distances. Consider comets. For centuries they were feared as omens, fiery apparitions in the sky, but up close, as missions like Rosetta revealed, comets are icy time capsules. Their frozen cores contain water, carbon compounds, even amino acids, the same building blocks that knit together into proteins on Earth. Each time a comet brushes past a planet or collides with a surface, it delivers part of that cargo. Imagine it as a cosmic letter sealed billions of years ago, finally arriving in the right mailbox. Asteroids, too, are not as lifeless as once assumed. Some contain clays, hydrated minerals, and traces of organics preserved from the earliest days of the solar system. When fragments of these asteroids fall as meteorites, we sometimes find within them complex molecules, including amino acids that display a curious preference for the same handedness used by life on Earth. Such finds whisper of a strange kinship, as though the universe keeps writing with the same alphabet, even in distant corners. Now imagine the moon, silent and exposed, sitting for billions of years under this cosmic rain. Each impact that struck its surface, each comet grazing, each asteroid fragment falling may have scattered seeds of organic chemistry. On the sunlit plains, much of it would vanish, vaporized by heat or stripped into space. But in the South Pole's eternal shadows, where the cold is absolute, these seeds could survive, protected, preserved, waiting. It is a gentle thought, almost tender, that while Earth was nurturing its oceans and forests, the moon was keeping safe a small collection of cosmic seeds, not to grow, not to flourish, but simply to endure. A different kind of garden, one without flowers or rivers, but with potential nonetheless. Imagine looking up at the night sky in deep time, long before cities, long before history. There would have been nights when the heavens flared with streaks of light, not just the delicate trails of a meteor shower, but torrents of fire as comets and asteroids swept through. To us now they are spectacles, but in those ancient eras they were also deliveries. Each falling star carried with it more than stone and ice. Each was a courier, scattering parcels of chemistry across the surfaces they touched. The moon, without the shield of an atmosphere, would have felt every blow directly. On Earth, many meteors burn away in a blaze of heat before they ever touch the ground. But on the moon, they strike unimpeded, leaving scars that still pockmark its face. And with each impact, fragments of ice, carbon, and organics would have been sown into the soil. Some of it would have vanished instantly under the harsh sun, sublimated back into space, yet the portions that tumbled into the polar shadows found sanctuary. Think of the South Pole craters as cosmic barns, wide open to the sky but forever dark inside. Over billions of years, they have quietly gathered these scattered seeds, layer upon layer, water molecules frozen beside simple hydrocarbons, ammonia nestled next to carbon dioxide, traces of amino acids perhaps, delicate as whispers, pressed into the regolith like faint imprints of letters. No farmer tended this garden, no rain or soil coaxed it into growth, and yet it became a storehouse, preserving what the universe had chosen to scatter. This is the strange patience of the lunar South Pole. While Earth teemed with change, with oceans rising and continents shifting, the moon remained still. It had no seas to dissolve these molecules, no winds to erase them. Its shadows simply received and remembered. A chemistry archive, built not by design but by time itself. And when we imagine those seeds lying in the dark, the picture is almost tender. It is as if the universe has been keeping a small box of treasures tucked away, a reminder that the story of life is not confined to Earth alone. Even if no living thing has ever stirred there, the raw ingredients, the alphabet of possibility, are waiting quietly, frozen into permanence. There is a quiet beauty in this idea, that the moon, so barren to our eyes, might be holding the same fragments that once rained upon Earth. Seeds scattered not with intent but with abundance, drifting across the solar system like pollen on a cosmic breeze. Some fell into oceans where they dissolved and danced into the chemistry of life. Others landed in silence, in places too cold or too dry to awaken. Yet all of them were part of the same scattering, the same experiment written across worlds. When we study meteorites that have fallen to Earth, we sometimes find amino acids tucked inside, molecules that survived the fire of entry and the violence of impact. If such delicacy can endure that journey here, how much more might survive on the moon, where seeds fell into craters that never warmed, never melted, never moved. And so the shadows of the lunar South Pole become more than geological features. They are listening posts, keeping safe the evidence of a universal generosity. The cosmos did not scatter these molecules in one place only. It spread them widely, as though saying, wherever there is a chance, let life have its chance. This is the deeper pull of panspermia. It is not just about comets and collisions, but about a sense of unity, a feeling that Earth and Moon, Mars and Europa, every icy rock and drifting world, all belong to the same unfolding story. Each is a page, written in the same alphabet, carrying the same seeds, waiting for the right moment to bloom. And perhaps that is why we return, again and again, to gaze at the moon. It is not only a companion in our night sky, but a reminder that we are part of something larger, that the ingredients of life are not rare jewels but scattered gifts, lying patiently in shadows until curiosity brings them into light. Which is why, today, so many missions set their sights on the South Pole. Scientists, engineers, explorers, they're all leaning closer to the moon's dark craters, hoping that by brushing away the dust and unlocking the ice, they will also open a door that leads not just to resources, but to understanding. For most of human history, the moon was untouchable, a silver lantern above fields and oceans, always near, yet always beyond reach. Then, in the brief span of the Apollo years, we touched it. Astronauts walked its plains, raised flags in the dust, brought back rocks that still sit in glass cases today. And then, for half a century, silence. The moon watched as our attention drifted elsewhere, to orbiting stations, to the dream of Mars, to telescopes peering out into the deep beyond. But in recent years, the moon has begun to call us back. Not the bright, familiar face we see from Earth, but the shadowed South Pole, where mysteries hide in cold craters. It is as if those dark hollows have become a stage, and the world's space agencies are gathering their lanterns at the edge of the curtain. NASA's Artemis program is perhaps the most visible light among them. Its name, drawn from the twin sister of Apollo in ancient myth, suggests not only a return, but a widening of vision. Artemis is designed not for a single visit, but for permanence, for building the skills and structures that could sustain a human presence on the moon. And the South Pole is its destination. Here, in those icy shadows, astronauts may one day collect samples with their own gloved hands, test equipment in the very conditions that future explorers must endure, and perhaps take the first steps toward building a lunar outpost. India too has stepped into this quiet race, not with the towering budgets of the United States, but with persistence and ingenuity. Its Chandrayaan missions have become milestones in their own right. The first revealed the signature of water ice. The second, though it stumbled in its landing, carried forward the dream. The third succeeded where the second had failed, touching down softly near the South Pole and extending the reach of humanity's eyes and instruments. For India, this was more than science. It was a moment of pride, a reminder that even nations once on the margins of the space age can now etch their names into the story of the moon. Alongside the giants, smaller voices are rising too. NASA has begun a program known as the Commercial Lunar Payload Services, often called CLPS. These are not grand rockets carrying astronauts, but modest robotic landers built by private companies. They are like small lanterns sent ahead into the darkness, each carrying instruments to sniff the soil, measure radiation, and test how fragile machines endure the cold. Though less dramatic than a crude landing, they represent a quiet revolution. By inviting many players to the stage, the moon becomes not just a symbol of national prestige, but a shared workshop where ideas from universities, startups, and laboratories around the world can find a place in the dust. Japan, too, has traced its path toward the polar shadows. With its slim mission, nicknamed the Smart Lander, Japan demonstrated precision in touching down, showing that it is possible to choose a landing site as carefully as a gardener placing a seed. That technology may one day allow scientists to set down instruments exactly inside the rim of a crater that has never known sunlight. Europe, though slower to plant its own flag, has quietly lent its hands as well. Through the European Space Agency, instruments and collaborations flow into Artemis and into robotic missions, ensuring that when discoveries are made, they are made together. The South Pole is no longer one nation's frontier. It is a meeting ground, a place where the ambitions of many converge like rivers into a single sea of ice. And then there is China, whose Chang'e program has steadily advanced step by step, from orbiters to landers to sample returns. Its eyes, too, are on the South Pole. Future missions promise rovers designed for the long shadows, and even whispers of bases built from the moon's own soil, sintered into bricks by concentrated sunlight. Whether these dreams come soon or slowly, they remind us that the competition is not only for glory but for knowledge, for resources, and for the story of who will first unlock the secrets of the frozen craters. In this gathering of nations and companies, one can almost imagine the South Pole as a stage encircled by watchfires. Each agency, each mission, each small probe is a flame flickering against the darkness. Together they sketch the outline of a new chapter in exploration, a chapter where the moon is no longer a silent witness but an active partner in humanity's journey outward. Picture it for a moment. From above, the South Pole of the moon is a crown of jagged rims and eternal night, and all around it, the hum of human effort grows louder. Rockets rise from distant continents, robotic scouts shuffle down crater slopes, antennas lean in from Earth to catch their faint voices. It feels almost like a caravan arriving at the edge of a desert. Each traveller brings their own supplies, their own dreams, yet all are drawn by the same shimmer on the horizon. This gathering at the South Pole is more than a competition. It is a convergence. Science hopes to find the record of our solar system, preserved in ice. Industry dreams of resources that could fuel a permanent presence. Philosophers see in it a mirror of our curiosity, proof that we cannot resist leaning into the shadows to see what lies beyond. The moon, once a destination visited briefly and left behind, is becoming a companion once more, one whose secrets may guide us further than we have ever gone. And yet, as the probes land and the missions multiply, there is a sense of anticipation that goes deeper than practical needs. It is the quiet thrill of approaching a place where answers might wait. Answers about history, about chemistry, and perhaps even about life itself. In the stillness of those frozen craters, humanity is gathering at the threshold of mystery. It is here, at this very edge, that strange questions begin to stir. If the moon's south pole is a vault, then what exactly lies locked inside? Are there signals, faint and puzzling, that suggest the story is more than geology and ice? When explorers peer into the South Pole, they do not always find silence. Sometimes, the instruments return whispers that seem to carry more than the expected echo of stone and ice. These are not the kind of signals that fill headlines with certainty. They are subtler than that. Small anomalies, like ripples in a pond whose surface should have been still. One of the most intriguing came from a radar experiment called Mini-RF, a small instrument flown aboard an orbiter. Its task was simple: to map how radio waves bounce back from the lunar surface. In most places, the echoes behaved as they should, scattering in predictable patterns that match dust and rock. But in certain craters near the South Pole, the radar waves returned with an unusual brightness, a kind of persistent sparkle. Some scientists interpret this as the signature of buried ice, hidden beneath the dust, reflecting the waves like mirrors tucked under blankets. Others caution that the same effect could arise from jagged boulders or fractured terrain. In either case, the echoes carry an allure. They hint that the craters may be holding more than meets the eye. Thermal instruments have added their own quiet puzzles. By measuring how quickly the surface warms and cools, they reveal textures invisible to the naked eye. At the rims of some polar craters, the heat seemed to linger in ways that suggested something denser, something that stored warmth differently than loose dust. Was it simply rock compacted by ancient impacts, or a trace of ice changing the way heat flows? The data does not decide for us. It only raises the question and leaves us standing in the dark, wondering. To the human imagination, these hints are like distant lanterns. They do not yet light the whole landscape, but they suggest that something lies beyond the darkness, waiting to be understood. The Lunar Reconnaissance Orbiter, a spacecraft that has circled the Moon for more than a decade, has been another quiet collector of mysteries. Its instruments trace the surface in exquisite detail, mapping craters, cliffs and shadows with the patience of a scribe copying ancient manuscripts. In the South Polar regions, its readings have hinted at places where the light behaves oddly. Sunlight that should scatter in one way sometimes returns in another, as if brushing across something smoother or more crystalline than expected. These shifts are not dramatic, but in the language of science they are the kind of subtle inflections that invite debate. Consider the way light glints on ice compared to dust. On Earth we know the shimmer of frost on a window pane or the glitter of snow beneath a full moon. On the lunar South Pole, instruments sometimes catch reflections that echo that familiar brightness. Yet the data remain ambiguous. Is it truly ice hidden in the shadows, or simply rock angled in such a way that it deceives the instruments? The moon does not answer. It offers a riddle instead. Even the way the soil reflects radar pulses has added to the puzzle. In certain craters, the return signal suggests that beneath the topmost grains lies material that is unusually transparent to radio waves. To some researchers, this is the fingerprint of water ice, perhaps buried in sheets or intermixed with the regolith. To others, it could be nothing more than shattered rock, its voids and fractures scattering the signal in ways that mimic transparency. In either case, the results leave open doors rather than closing them. Temperature maps tell a similar story. At the South Pole, where the sun barely skims the horizon, surfaces behave like instruments themselves, recording the passage of heat. Some crater floors remain locked in bitter cold that never shifts. Others retain warmth longer than expected, as if something beneath the dust holds it steady. To walk across such places, if one ever could, might feel like stepping from one page of a book to another, each with its own tone and rhythm, each refusing to reveal the whole story at once. And through all of these instruments, what emerges is not a clear conclusion, but a chorus of small peculiarities, bright echoes, lingering heat, odd reflections. None of them prove the presence of ice or organics or anything more exotic, yet together they weave an atmosphere of possibility. They remind us that science often begins not with certainty but with curiosity, not with final answers but with faint signals that invite us to look closer. Perhaps the most haunting quality of these anomalies is how quiet they are. They do not shout. They do not draw lines of certainty. Instead, they drift back across the void as murmurs, like the faintest notes of music played on an instrument long out of tune. Radar echoes that gleam a little brighter than expected. Shadows that seem to cradle reflections where none should exist. Heat that lingers in patterns no one can fully explain. To the scientist, they are puzzles awaiting more data. To the dreamer, they are whispers, hints that the moon might be guarding something more than rock and ice. It is in this space between evidence and imagination that curiosity takes root. The signals are neither confirmations nor illusions. They are possibilities, suspended in the silence of space, asking us to lean closer, to listen harder, to wonder more. And so the South Pole remains like a closed book lying on a bedside table. We run our fingers over its cover, sensing the weight of stories inside, but the pages are not yet turned. Every echo, every shimmer, every unexplained warmth is a word we almost recognize, a fragment of meaning left deliberately incomplete. This is the strange beauty of exploration, that long before we hold answers in our hands, we hold questions in our hearts, and in those questions lies the fuel for every journey still to come. Which brings us to the delicate balance that follows, the promise of discovery and the peril of disturbing what has waited untouched for eons. There is a fragile line that runs through every story we tell about the moon's south pole. On one side lies science, grounded in measurements and instruments, a careful layering of data that can be repeated and confirmed. On the other side lies speculation, those gentle leaps of imagination that try to fill the silence with meaning. And in between stretches a wide twilight zone where numbers blur into possibilities, and possibilities are easily dressed as truths. When a radar pulse shines into a crater and returns brighter than expected, the science says only this: the surface reflects differently here. The speculation whispers, perhaps it is ice. And the imagination rushes further still, suggesting that where there is ice, there might also be life. Each step is understandable, each step is tempting, yet each one also takes us further from the original signal. This is not a flaw of curiosity, but its natural rhythm. Our minds are storytellers. We do not like empty spaces, so we fill them. A faint shimmer becomes a signpost. A strange echo becomes a clue. And soon, before we even notice, we are speaking not about what is measured, but about what is hoped. The media often carries this rhythm forward with its own amplifying voice. A cautious scientific report may say that ice could exist in certain shadowed regions. A headline may declare instead that water has been found, as though explorers were already scooping it with their hands. What begins as a possibility becomes, in the public imagination, a fact, and what begins as a question is retold as an answer. For the moon, this tension is especially sharp. It is close enough to feel familiar, yet distant enough to remain mysterious. It invites us to believe that its secrets are just within reach, that with one more mission, one more instrument, the truth will at last be revealed. And so each anomaly carries a double weight. It is both a data point in a chart and a spark for the human longing to know more than the data alone can tell. Think of it like walking along the shore at night. The waves roll in and out, leaving patterns in the sand. Some are sharp and clear, like a footprint pressed deeply. Others are vague swirls, hints of motion whose origin you cannot quite see. Science is the act of measuring those prints carefully, deciding which belong to people, which to birds, which are only shapes left by the tide. Speculation is when we begin to imagine stories of who passed this way, why they walked here, and where they were going. Both are part of the same experience, but they are not the same thing. On the moon, the footprints in the sand are echoes of radar, flashes of light, and maps of temperature. They tell us something happened, that the surface behaved in a certain way, yet interpretation is always a step beyond. When scientists note unusual radar reflections, they remain cautious, speaking of possible ice or unusual rock textures. But in the hands of storytellers, those careful words often become declarations that water is waiting in hidden pools, ready for astronauts to drink. The line between observation and conclusion is stretched until it nearly disappears. And then there are the stories that go even further, drifting beyond science into the territory of myth. A shadowed crater becomes not just a geological curiosity, but the imagined hiding place of alien artifacts. A thermal anomaly is retold as the warmth of something alive beneath the dust. These leaps capture attention, they spark wonder, but they also risk drowning out the quieter truth that we do not yet know. Still, to dismiss speculation entirely would be unfair, for speculation, in its gentlest form, is what drives the questions forward. Without the whisper that ice might be hiding there, we might never have pointed instruments toward those craters. Without the dream that life could adapt to extreme conditions, we might never have discovered the hardy microbes that thrive on Earth in places once thought barren. Curiosity blooms in the space between evidence and imagination. The danger lies not in speculation itself, but in forgetting where the evidence ends and the imagining begins. Perhaps this is the true enchantment of the South Pole of the Moon. It does not hand us answers in neat boxes. It gives us hints, fragments, puzzles that can be read in more than one way. To the careful scientist, they are data to be tested again and again. To the dreamer, they are doorways, each leading to a corridor of possibility. And somewhere in the middle, in that twilight between caution and wonder, humanity finds its deepest curiosity. It is easy to wish for certainty, to crave a headline that declares once and for all that water is here, that life is possible, that mystery has been solved. But in truth, the lingering questions are what keep our gaze lifted. The moon remains captivating precisely because it has not yet surrendered its secrets. The shadows still whisper, rather than speak. The echoes still shimmer without revealing what lies beneath. And so we stand in that delicate space where science and speculation lean against one another. One provides the structure, the other the colour. One ensures that our steps are firm, the other ensures that we keep stepping forward at all. The balance is fragile, but it is also fertile. Out of it grow missions, experiments, stories, and dreams. It is, at this edge, where evidence meets imagination, that we now turn our eyes back to Earth. For if we are to wonder whether life could persist in the frozen vaults of the lunar South Pole, we should first ask, where on our own world has life already proven its ability to endure the impossible? When we wonder whether life could hide in the frozen vaults of the lunar South Pole, our minds are quickly drawn outward, to worlds far from Earth where darkness, ice, and chemistry dance together in strange symphonies. Two of the most compelling examples are Europa, the icy moon of Jupiter, and Enceladus, the shimmering pearl orbiting Saturn. Europa wears its mysteries like a sheet of glass. Beneath its cracked surface of ice lies an ocean vast enough to drown all the seas of Earth combined. No sunlight reaches that abyss, yet the pull of Jupiter's gravity stirs the waters from within, creating tides that rub the seafloor and release warmth. There, in total darkness, vents may billow with chemicals, offering energy not from the sun, but from the heart of the planet itself. To imagine microbes swimming in those hidden waters is no longer fantasy. It is a possibility that grows stronger with each measurement, each image of surface fractures where the ocean may be whispering up to space. Enceladus is smaller, but in some ways even more dramatic. From cracks near its south pole, geysers of water shoot into the void, plumes glittering in the sunlight like breath on a winter morning. Spacecraft that have flown through these plumes found grains of salt, hints of organics, and the unmistakable fingerprint of subsurface water. Beneath the crust of ice, a hidden sea is alive with motion. It is not alive in the sense of teeming creatures we can yet confirm, but alive with energy, with the raw materials that on Earth are always companions to life. Both Europa and Enceladus remind us of a simple truth. Life does not demand sunlight alone. It can take root in the shadows, drawing power from chemical reactions, thriving in silence where no sky is visible. They are proof that darkness is not emptiness, that cold is not death, but that within such extremes there can still be warmth enough for survival. And when we bring these images back to the moon, the comparison becomes strangely comforting. For while the lunar South Pole does not promise deep oceans or dramatic geysers, it does offer darkness, ice, and the possibility of chemistry stirred by time and radiation. In its stillness we hear faint echoes of these faraway worlds, as though the moon, too, might be a quiet sibling in the family of icy sanctuaries. On Europa, the surface looks fractured and scarred, like a frozen desert that has been cracked open by invisible hands. Yet those scars may be windows, places where the inner ocean breathes faintly into space. Imagine standing on such a plain, the stars above hidden behind a pale sheet of ice, while beneath your feet an entire sea presses upward, restless and unseen. The lesson Europa offers is that life can be shielded by ice rather than nourished by sunlight. Protection and isolation can be gifts, preserving oceans that would otherwise have vanished to the cold. Enceladus teaches another lesson, one that feels even closer to the human heart. Its plumes are like a whisper that refuses to be silenced. With every eruption, it scatters droplets of its inner ocean into the void, as if saying to the cosmos, "Here is a piece of me, here is my secret." Those droplets, when caught by spacecraft, carried hints of organics and energy sources, suggesting that chemistry is alive and evolving below. It is a reminder that even the smallest worlds can hold stories grand enough to change our understanding of what it means to be habitable. When we compare these distant moons with our own companion in the night sky, we find a curious kinship. The lunar South Pole may not erupt with fountains of water, but its shadowed craters hold a quieter promise. The ice there is not fed by deep oceans, but by billions of years of accumulation from comets, solar wind, and cosmic debris. And yet, like the oceans of Europa and Enceladus, this ice has been sheltered in the dark, protected from the touch of sunlight, preserved like a time capsule. The chemistry may not be as rich, the environment may not be as generous, but the principle is the same. In the universe, survival often depends less on abundance than on protection. It is not about how much warmth or light a place receives, but about whether fragile molecules can persist long enough to matter. In this way, the Moon's south pole and the icy worlds of the outer solar system share a quiet echo. Each tells us that where ice and darkness meet, there may also be the possibility of life. The parallels between these icy moons and the south pole of our own moon are not claims of certainty, but invitations to imagine. Europa with its hidden tides, Enceladus with its shimmering plumes, and the lunar craters with their ancient frost all sing variations of the same melody. It is a melody about resilience, about chemistry cradled in darkness, about the universe's stubborn refusal to let potential slip away entirely. No one suggests that the moon hides oceans vast enough for whales, or geysers that glitter like fountains in sunlight. Its promise is quieter. It lies in the possibility that fragments of chemistry, preserved across billions of years, might echo the same conditions that elsewhere allowed life to stir. The moon is not shouting its story, it is humming softly, and we lean in close, hoping to catch the tune. And perhaps that is the greatest lesson of Europa and Enceladus for us here at home, that when we look at the south pole of the moon, we do not see an isolated world, but a participant in a grander pattern. A pattern where ice and shadow and chemical energy weave together across distant spheres, reminding us that the conditions for life are not a singular accident but a recurring theme. So, as we turn our gaze back to the frozen craters near our own doorstep, the question becomes sharper and more personal. If life has proven it can thrive in darkness and ice elsewhere, could it, in some fragile and hidden form, also survive in the shadows of our moon? For as long as we have looked at the moon, it has been a canvas for our imagination. Its glowing face has inspired myths of gods and lovers, animals and omens. In the modern age, when telescopes and spacecraft began to reveal more detail, that imagination did not fade, it simply took new shapes. Among the most persistent is the idea that the moon, especially its darkened craters and hidden poles, might be home to alien bases. The story is compelling because it blends the familiar with the mysterious. The moon is near enough that we see it every night, yet distant enough that most of it remains unknown to our eyes. Add to this the unsettling emptiness of its south pole, a place where the sun never rises, and the stage feels ready for speculation. If there were ever a place to hide something extraordinary, many people think, surely it would be there. Photographs taken by orbiters sometimes show geometric shadows, sharp angles carved by craters or boulders, which to the human eye resemble structures. A play of light and perspective becomes, for some, the outline of walls or towers. The mind is quick to connect dots, to trace meaning where none may exist. Just as ancient stargazers saw hunters and lions in the stars, modern dreamers see domes and corridors etched into lunar stone. These ideas travel quickly in the digital age. A single image, shared without context, can ripple across forums and videos, carrying with it claims of cover-ups and hidden truths. The notion that space agencies might be concealing alien outposts feeds into older stories of secrecy and control. For many, the absence of evidence becomes not a reason for doubt, but the very proof they need. Yet when scientists look at the same images, they see the natural language of geology, cracks where rock has fractured under stress, shadows lengthened by the low sunday, patterns etched by impacts over billions of years. There is no evidence, they remind us, of artificial structures, no trace of machinery, no signals of technology. The moon speaks in dust and silence, not in towers or bases. Why do such stories persist, even when evidence remains absent? Perhaps it is because the human mind has always been drawn to the idea of hidden realms. We find comfort in believing that behind the veil of the ordinary, something extraordinary might be waiting. The moon, with its familiar glow yet inaccessible surface, becomes a perfect mirror for that longing. In earlier centuries, people imagined cities on Mars or civilizations on Venus. Today, those worlds are known to be barren, but the yearning has not faded. It has simply shifted focus, finding new homes in the darker corners of our imagination. The south pole of the moon, shrouded in eternal night, provides fertile ground. If one cannot see what is there, one is free to imagine anything at all. The spread of such myths also speaks to our desire not to feel alone. An alien base on the moon, no matter how improbable, suggests that we share this universe with others, that the long silence of the stars might one day break into dialogue. To believe in structures hidden in the shadows is, in some ways, to believe that we are not abandoned in the vastness. It transforms the moon from a cold stone companion into a neighbour that is shared, perhaps even visited by intelligence beyond our own. Modern technology gives these dreams new wings. A blurry photograph, cropped and magnified, becomes proof to some eyes. A reflection of light across a crater rim is described as a shining dome. Videos with dramatic music and suggestive narration spread through the internet like wildfire, each view reinforcing the idea that there must be something more. These stories thrive not because they are confirmed, but because they are alluring. They offer a narrative richer than dust and ice, a narrative in which the moon is not silent but inhabited. Scientists often remind us that extraordinary claims require extraordinary evidence, yet myths endure precisely because they live in the space before evidence. They are not built to be tested, but to be told, shared, and believed. In that sense, the alien base is less a discovery than a reflection of human imagination itself, cast upward onto the canvas of the night sky. In the end, when the dust of rumour settles, what remains is quiet. No spacecraft has photographed machinery resting in a crater. No sensor has recorded transmissions from hidden towers. No astronaut has stumbled upon corridors carved into lunar stone. There is no evidence, only shadows that our imagination has dressed as secrets. Scientists return again and again to this point, reminding us that the moon's mysteries are geological, chemical, and physical, not architectural. And yet, perhaps we should not dismiss these myths too quickly. They are not truths, but they are part of our story. They show how deeply we wish to find company in the universe, how strongly we lean toward wonder even when data holds us back. The alien base is not a discovery but a dream, and like all dreams, it tells us something about the dreamer. So, while science gives us careful maps and cautious conclusions, the myths remind us of the human heart behind the telescope, the heart that gazes upward and longs for connection, that whispers into the silence, asking if anyone is listening back. The moon, in its stillness, becomes a stage where our fears and hopes are projected, even if the stage remains empty. And this too has meaning. For when we imagine alien footprints in the dust, we are also imagining the responsibility that would come if such a discovery were real. How would we protect it? How would we preserve it? These questions, though sparked by myths, carry us into the very real discussion of how to guard the purity of untouched worlds. For all the whispers of mystery, there is also a practical truth about the lunar South Pole. It is not only a place of questions, but a place of potential. To those who dream of one day establishing a lasting human presence beyond Earth, the South Pole is less a distant enigma and more a key. The first reason lies in its hidden reservoirs of ice. Water, carried over eons by comets and preserved in the eternal shadows, is more than a scientific curiosity. It is the foundation of survival. From water comes not only drink but oxygen for breath and hydrogen for fuel. In the cold vaults of these craters rests the possibility of sustaining astronauts without depending entirely on fragile supply lines, stretched across hundreds of thousands of kilometers. But the South Pole offers more than ice. Along the rims of its great craters, sunlight lingers in a way that is rare elsewhere on the Moon. Because of the slight tilt of its axis, certain peaks remain brushed by light for most of the year. These places have been poetically called peaks of eternal sunlight. They are not eternal in the strictest sense, but they offer illumination far longer than the brief and punishing day-night cycles elsewhere on the lunar surface. To engineers and planners, such ridges are golden ground. They provide power for solar panels, warmth against the bitter cold, and stability for operations that might stretch across months. Together, the shadows and the light create a paradoxical harmony. In the depths of the craters lies the water that sustains life. On the illuminated edges lies the power that enables it. Between the two, a natural rhythm emerges, as if the Moon itself were offering the conditions for a foothold. Not a lush cradle like Earth, but a carefully balanced threshold, where human ingenuity could extend itself outward into permanence. When visionaries speak of the South Pole as a stepping stone, they are thinking not only of survival but of logistics. The Moon is close enough to Earth that travel is possible within days, yet distant enough that each kilogram of cargo costs dearly. To bring water, oxygen, or fuel from Earth for every mission would be like trying to climb a mountain while carrying the mountain itself on your back. It is possible for a while, but never sustainable. Here the South Pole offers a remarkable alternative. Ice mined from shadowed craters could be split into its elements, oxygen and hydrogen, to provide breathable air and rocket fuel. Imagine a base where storage tanks slowly fill with these resources, ready not just for astronauts living nearby, but for spacecraft on their way farther out. The Moon could become a refueling station, a kind of cosmic harbour where vessels pause to replenish before sailing deeper into the solar system, and the ridges brushed with near-constant light make such operations feasible. Solar panels set along those luminous peaks could feed energy into habitats and machinery, powering the extraction of ice and the conversion of it into usable forms. Instead of fragile dependence on Earth, each mission could build upon the last, leaving behind infrastructure that grows like coral, layer upon layer, until a permanent outpost emerges. The geography of the South Pole also offers a subtle advantage in its line of sight. From certain high points, Earth remains visible above the horizon. This connection, constant and reassuring, allows communication to flow without the interruptions that plague other lunar locations. For settlers, knowing that the blue planet can be seen each day is more than practical. It is emotional. It is a reminder that they are never entirely alone, even while standing on alien soil. In this way, the South Pole becomes more than a destination. It becomes a bridge between temporary visits and lasting presence, between fragile expeditions and sustainable exploration. It holds within its ice and its light the possibility of turning the Moon from a silent neighbour into a shared frontier. To think of the lunar South Pole only as rock and shadow would be to miss its deeper meaning. It is, in many ways, a threshold. The first explorers who one day set foot there will not simply be astronauts gathering samples. They will be participants in a test that humanity has long been preparing for, a test of whether we can live beyond the world that shaped us. Every tent erected on those ridges of light, every machine lowered into those frozen craters, will be more than technology. They will be symbols of a turning point in our story. For thousands of years, the Moon has been a companion in poetry and myth. To make it a companion in daily life would be a profound shift. Settlements near the South Pole would be small at first, fragile outposts leaning on sunlight and ice. But over time, they could become havens of resilience. The craters that once symbolized emptiness would hold water to drink. The peaks that once seemed barren would hum with power. In that transformation lies a kind of quiet beauty, the turning of the moon from distant muse into partner. And perhaps the most haunting thought is that as we build there, we will carry with us not just tools but questions. What does it mean to place human footprints where silence has lasted for billions of years? What responsibilities do we inherit when we touch the frozen heart of another world? The South Pole is not only a resource but a reminder, whispering that exploration is always entwined with care. In its icy shadows and luminous ridges, the South Pole asks us to look both inward and outward. Inward, at the ingenuity and daring that allow us to reach beyond our cradle. Outward, at the mysteries that may yet wait in the darkness. For if the South Pole is a doorway, then it is not just a doorway to survival. It may also be a doorway to discovery, to the possibility that we are not alone after all. It is a question that lingers softly in the background of every mission and every plan. What if, hidden within the shadows of the South Pole, there truly is life? Not life as we know it on Earth, but something smaller, quieter, perhaps even stranger. To lean toward this question is to enter a realm where science and philosophy walk hand in hand. The first possibility is the most tantalizing. That life might be native to the moon. If tiny organisms had managed to take root in the icy craters, they would be unlike anything we have ever known. Born in an environment without atmosphere, nurtured only by chemistry and shadow, such beings would expand our definition of what it means to be alive. Discovering them would be like opening a door to a new chapter in biology, one written not on Earth but in parallel, reminding us that life is not a singular miracle, but a pattern the universe may write more than once. The ethical weight of such a discovery would be immense. Would we treat the moon not as a frontier to settle, but as a sanctuary to protect? Would mining and colonization be paused, reshaped, or even forbidden in order to safeguard a fragile ecosystem that has waited undisturbed for eons? The second possibility is more sobering. That if we do one day find microbes clinging to survival in those craters, they may not be lunar at all. They may be hitchhikers, carried on spacecraft or in the breath of astronauts, seeded unintentionally by us. In this scenario, the moon becomes less a birthplace of life than a mirror of our presence, altered by our touch. The ethical dilemma here lies in responsibility. How do we distinguish between life that belongs and life that was introduced? And if we are the source, does that lessen the wonder, or does it heighten the responsibility we carry as stewards of every place we set foot? Even this sobering picture carries weight, for it would remind us that our actions echo beyond Earth, that contamination is not only a scientific concern but a moral one. If microbes from our world can survive on the moon, then every landing, every sample, every footprint is part of an irreversible exchange between worlds. The third possibility is perhaps the quietest, but it may be the most likely, that beneath the dust and ice there is no life at all, only chemistry that hints at what could have been. Frozen molecules preserved for billions of years, fragments of organics delivered by comets or stirred into existence by solar radiation, lying dormant in the dark. They are not alive, yet they are not meaningless. They are like seeds that never sprouted, or notes of a song written but never sung. To uncover such relics would not diminish the wonder. On the contrary, it would remind us that the boundary between life and non-life is more delicate than we imagine. If the lunar South Pole holds amino acids or simple chains of carbon, then we would be staring at the alphabet of biology scattered across the cosmos. It would tell us that the universe is inclined toward complexity, that the leap from chemistry to biology may be less improbable than we once feared. Yet here too the ethical questions gather. If the moon holds these fragile signatures of prebiotic chemistry, what should we do with them? Do we mine the craters freely, knowing we might erase evidence of processes older than life on Earth itself? Or do we treat those molecules as heritage, as archives of cosmic history, preserved not for profit but for knowledge? The legal framework that governs outer space, shaped in treaties decades ago, speaks of celestial bodies as the province of all humankind. But those words were written in an age when the moon was untouched and distant. Now, with missions poised to land at its south pole, The treaties feel less like guiding stars and more like fragile glass in our hands. They do not tell us what to do if we find the beginnings of life. They do not tell us how to weigh commerce against preservation, ambition against humility. In this space of uncertainty, philosophy steps in. Some argue that even prebiotic chemistry deserves protection because it represents the first line of a story that could, under different circumstances, have become life. Others argue that we must balance protection with progress, that humanity cannot halt exploration out of fear of disturbing shadows. Between these poles lies a spectrum of choices, none of them simple, all of them profound. When we gather these three possibilities side by side, the picture becomes less about certainty and more about reflection. If life has sprung from the moon itself, then we are no longer unique. Our universe is fertile in more than one corner, and our duty becomes one of guardianship, protecting what has managed to endure in silence for so long. If the life we find is only our own, carried inadvertently across the void, then the discovery shifts inward. It asks us to confront the reach of our presence, to recognize that every footprint is a seed, every journey an act of transformation for the worlds we touch. And if what we find is not life but only the faint outlines of chemistry, then even that is a gift, a reminder that the cosmos has been experimenting with possibility since the beginning of time. In all three scenarios, the burden does not vanish. Instead, it grows. For to know that life or its shadow exists is to know that our choices matter. To harvest ice for fuel without care could erase records more valuable than any mineral. To settle on crater rims without reflection could overwhelm fragile traces that might have whispered to us of origins. The responsibility is not only scientific but moral, woven through with questions about what kind of species we wish to be when we step beyond Earth. And here the law becomes less of a shield and more of a question mark. Treaties can declare that no nation owns the moon, yet treaties cannot tell us how to treat a microbe if we find one. They cannot tell us whether a strand of prebiotic molecules deserves the reverence of a museum or the utility of a fuel source. Those choices will fall to us, shaped by our philosophies, our compassion, and our willingness to see value not only in wealth, but in wonder. Perhaps then, the greatest truth of all is that the moon's south pole is a mirror. In its shadows we will not only search for life, but also discover what it means to be human. Do we seek to conquer, or do we learn to listen? Do we rush to extract, or do we pause to preserve? The answers we choose will echo far beyond the craters. They will shape how we approach every new horizon, from Mars to the icy moons of the outer planets. And so, as the questions linger, we are reminded that discovery is rarely instant. The universe asks us to wait, to listen, to wonder. The proof, if it comes, will come slowly. Until then, it is the waiting itself that keeps our imagination alive. There are moments in human history when a discovery, no matter how small in size, reshapes the entire horizon of thought. One can imagine Galileo lifting his telescope and realizing that Jupiter has moons of its own, or Darwin turning over the fossil of a creature that no longer walks the earth. These are moments when the world, once familiar, becomes newly vast. The same could happen again if beneath the dust and ice of the lunar South Pole, even the faintest whisper of life were found. Picture it, a speck of organic residue sealed in ancient ice, or a microscopic structure that bears the undeniable signature of biology. It would not need to be grand or complex. A single cell, long dormant, would be enough. That tiny presence would ripple through science, philosophy, culture, and identity with the force of an earthquake, shaking assumptions that have stood for millennia. The first ripples would touch science itself. For centuries we have treated Earth as the solitary cradle of life, a rare accident in an indifferent universe. If life also appeared on the moon, then the story shifts. Suddenly the emergence of life no longer seems like a miracle against impossible odds, but more like a natural tendency of the cosmos. Perhaps life blooms wherever there is water, protection from radiation, and the patience of time. The lunar South Pole would become not a barren neighbour, but a silent archive of this tendency. From the perspective of biology, such a discovery would mean that life is not an exception to the universe but one of its languages. The second ripple would run through our sense of identity. Humanity has always carried the quiet suspicion that we are alone. It is a suspicion heavy with loneliness, for even as we gaze at galaxies we see only silence. If life can exist in the frozen shadows of the moon, then solitude softens. We are no longer a singular spark but part of a wider constellation of being. Even if the life discovered is microbial, even if it never spoke or dreamed, its existence would alter the definition of us. The word neighbours would no longer refer only to those who share our planet. It would extend outward, across the void, to companions whose existence we had once doubted. The third ripple would shape culture. Myths, religions, philosophies and art have long placed humanity at the centre. Every worldview has, in some way, assumed our uniqueness. To discover life beyond Earth is to redraw that centre. We would no longer be the sole actors upon the stage of existence, but one voice in a cosmic choir. That realization could be humbling, but it could also be liberating. If we are not alone, then perhaps the story of life is not one of solitude, but of connection, of echoes finding each other in the darkness. Poetry would change. Lullabies would change. Even the way we teach children about the night sky would change, for they would know that among those cold lights, some are not empty, but inhabited. Science, identity, culture. These ripples would continue outward into law and responsibility. The treaties that govern space exploration were written under the assumption that celestial bodies are lifeless. They allow for mining, colonization, and resource use without much hesitation. But if the moon is home, even in the smallest way, to life, then every act of drilling or harvesting would become ethically charged. Do we have the right to disturb ecosystems, no matter how small, that predate humanity by billions of years? Or should we act as guardians, preserving them as treasures of cosmic heritage? The question is no longer hypothetical. It becomes urgent, pressing itself into every plan for the future. And consider the children yet to come. For them, the moon would not be a dead rock but a world with a story of its own. Imagine the textbooks rewritten to describe lunar microbes, or the classrooms where young minds learn that Earth was never alone. The moon, once the subject of lullabies and lantern festivals, would become a kind of relative, a place with kinship to life. In the eyes of a child, that knowledge could transform the way they look at the sky forever. No longer would the moon be only a symbol of longing. It would be proof that life is not confined to our fragile blue world. There is also the matter of time. If microbes have endured in the shadows for billions of years, waiting through eras when continents drifted and species rose and fell, then our own story feels small in comparison. Wars and rivalries, no matter how loud, would appear as brief flickers against such endurance. This contrast could shift our priorities. We might begin to see ourselves not as fleeting rulers of a planet, but as caretakers of something far older and more resilient. To find life in the moon's frozen vaults would remind us that survival is an art, and patience is its greatest tool. The implications reach further still. To care for life on the moon, we must first learn to care more deeply for life on Earth. How could we justify protecting microbes in shadowed craters while failing to protect forests, oceans, and climates here? The discovery would place a mirror before us, reflecting our contradictions. It would challenge us to reconcile our desire to explore with our duty to preserve. In this sense, the moon could become not only a destination but also a teacher, offering lessons about humility and responsibility. The cosmic implications also include the redefinition of hope. For generations, people have gazed upward, wondering if the universe holds neighbours. To find them so close, in our own celestial backyard, would be a revelation. It would suggest that the cosmos is alive with possibilities, that the silence of the stars may not be emptiness, but simply distance. Hope would shift from fragile wish to grounded expectation. If life can exist on the moon, then where else might it thrive? On Mars? In the oceans of Europa or Enceladus? On planets orbiting distant suns? The discovery would turn speculation into conviction. The universe is fertile, and yet, such a discovery would not answer every question. It would instead multiply them. What kind of life is it? Did it arise independently, or did it come from Earth carried by rocks or missions? Does it still endure, hidden from our sight, or is it only a relic of a past age? Each question would branch into others, and the pursuit of answers would drive generations of explorers. The mystery would not end. It would deepen, becoming an unending source of curiosity and wonder. The most profound implication, however, may lie in the expansion of empathy. We already find it difficult to extend compassion across our own species, across borders and differences. To extend it further, to microbes or tiny organisms that share nothing of our language or form, would be a test of imagination. Yet if we succeed, if we can feel kinship with even the humblest life in alien darkness, then we prove that empathy itself can grow beyond the boundaries of Earth. In that growth lies a vision of humanity not as conqueror, but as caretaker of the living cosmos. Finally, there is the personal implication. Imagine yourself standing under the night sky after hearing the news that life has been found on the moon. You look up, and the moon looks back, not as an empty mirror of light, but as a world with secrets, a world with kin. The thought may bring a shiver, or a smile, or perhaps a quiet peace, for in that moment you would know that the long silence of the universe has been broken. We are not entirely alone, the stars are not entirely empty, and the story of life is larger than we ever dared to believe. There is a certain kind of peace in leaving a question unanswered. We are often taught that mysteries exist only to be solved, that the value of a riddle is the answer hidden inside it. But the cosmos does not move by those rules. Its questions linger like distant echoes, calling us not to conquer them, but to rest within their music. The lunar South Pole, with its frozen craters and ancient shadows, is such a question. It does not beg for a solution. It invites us to listen. If you imagine standing at the rim of one of those craters, you would see no sunrise, no gleam of familiar warmth. You would see only shadow, deeper than any night on Earth, shadow that has stretched unbroken for billions of years. The cold there is not hostile so much as eternal, a stillness that hums with its own kind of silence. To peer into it is to look at time itself, preserved like a delicate fossil. And in that gaze, we might feel less the urge to dig, and more the urge to breathe softly, to bow in quiet recognition of something greater than ourselves. The human heart is not always comfortable with uncertainty. We want to measure, to record, to name, yet some truths slip through our nets no matter how fine they are woven. The possibility of life in lunar shadows may be one of these truths. Perhaps we will send probes and rovers and astronauts, and perhaps we will bring back samples that keep the mystery alive instead of dissolving it. That would not be a failure. It would be a reminder that wonder does not depend on clarity. Wonder depends on humility, on the courage to admit that the universe does not owe us explanations. Think of how children sometimes fall asleep with a question on their lips, a question that drifts away before morning comes. The question itself becomes part of their dream, blending with images of stars and oceans. In the same way, humanity might cradle the question of lunar life as a kind of cosmic lullaby. We do not need to know tonight. It is enough to ask. It is enough to let the asking soothe us. Even our myths whisper the same lesson. The moon has always been more than light in the sky. It has been a mirror of longing, a symbol of cycles, a companion to lovers and poets alike. Rarely has it been seen as something to be fully understood. More often it has been held as mystery itself, a face half hidden, a lantern half veiled. In this way, to leave the question of its hidden life unanswered is not a loss. It is a return to an older way of seeing, one that honours the unknown rather than rushing to extinguish it. And perhaps, when all is said and done, the South Pole's deepest gift is not evidence of microbes or molecules. Its gift may be the stillness it awakens in us, the stillness of realising that some corners of the universe remain untouched, and that our place within it is to marvel, not to master. The shadows of the moon may never whisper a direct answer, but they can whisper peace, they can whisper perspective. They can whisper the gentle truth that life is richer when it contains mystery. The south pole of the moon is a library where the books are written in silence. Each crater is a volume, each frozen deposit a page. But unlike the libraries of Earth, this one does not yield its knowledge to eager hands. It waits, closed and timeless, holding its secrets as though to remind us that not all stories are meant to be read quickly. Some stories are meant to be felt, as one feels the hush of snowfall or the stillness of a midnight forest. When we imagine explorers standing there in the far future, perhaps in suits glowing faintly against the darkness, the image is not only one of conquest, it is also one of reverence. To look into those eternal shadows is to be reminded of the humility required for any true journey. The shadows do not rush. They do not change to accommodate our schedules. They teach us the slow rhythm of the cosmos, where 1 billion years can pass like a breath. If we listen, we may find our own pace softening, our own thoughts quieting into something gentler. The ice itself is a kind of time capsule. Imagine crystals forming in an age when continents on Earth had not yet taken shape, when the seas were young and life itself was still learning to breathe. Those crystals remain, untouched, layered upon each other like the rings of a tree. To break them open is to touch the dawn of the solar system. But even without breaking them, to simply know they exist is enough to shift the imagination. They are reminders that time is not always linear, that memory can be stored in silence waiting for a patient gaze. Sometimes, the greatest gift of a mystery is the way it makes us slow down. To wonder whether life might sleep in those shadows is to pause and consider what life itself means. Is life only motion and activity, or can it also be the potential for motion, the possibility of awakening? In this sense, the South Pole becomes a metaphor for us, for we too carry questions that may never fully awaken, dreams that remain dormant but precious. To honour them is to honour the quiet corners of our own being. There is also a kind of tenderness in not knowing. When we look at the moon from Earth, we already know so much, its cycles, its orbit, its effect on tides. But to leave one part of it wrapped in uncertainty is to preserve intimacy, as though the moon still keeps a secret, even after all these centuries of watching us. That secret becomes a bond, an unspoken promise between the Earth and its companion. We may study, we may measure, but we will never fully possess, and perhaps that is how it should be. The shadows then become not a void, but a presence. They are not empty, but full of quiet possibility. Whether they hold microbes or molecules, or only silence itself, they serve as a canvas on which our longing is painted. Every question we ask of them becomes part of the story. Every unanswered question becomes another star in the constellation of our wonder. Perhaps the deepest gift of the lunar South Pole is the way it invites us to let go. We do not need to solve everything tonight. We do not need to name every silence or pierce every shadow. Sometimes, the greatest wisdom is to allow mystery to remain, to lie beside us like a companion in the dark. To hold a question without an answer is a form of trust, a recognition that the universe is vast enough to contain both knowledge and wonder. When you look up at the moon after hearing all these stories, you may find your gaze softer. The glow that once seemed cold might feel more like a lamp left on in another room, its door slightly ajar. You know there is something inside, though you cannot yet see it, and rather than frustration, that uncertainty brings comfort. For the light assures you that the room exists, that the house of the cosmos is larger than you thought. It is possible that one day we will find life there, fragile and patient, enduring against all odds. It is also possible that we will find only frozen silence, unbroken and pure. Both outcomes hold beauty. Life would tell us that we are not alone. Silence would remind us that our questions are part of what makes us human. Either way, the shadows do their work. They turn our eyes upward. They keep our imaginations awake even as we drift towards sleep. And so, as we close this quiet journey, let us remember that not every voyage seeks a destination. Some voyages exist for the drifting itself, for the gentle rhythm of asking, for the calm that comes when we accept that the night does not need to be solved. The lunar South Pole, with its eternal shadows, becomes less a puzzle than a lullaby, a melody of silence sung across space. May that lullaby accompany you tonight. May it settle into your thoughts like falling snow, light and unhurried. May it remind you that the universe is vast, that we are small, and that smallness itself is a kind of grace. And as your eyes grow heavy, let the questions linger like stars at the edge of vision, twinkling softly, not demanding to be answered. For in the end, perhaps the truest gift of the moon's shadows is not knowledge but rest. To gaze into them is to remember that it is all right not to know, all right to be carried by wonder. And in that remembering, sleep comes easily, like a tide guided by the moon itself. And so, dear traveller, we leave the lunar South Pole behind us for tonight. We have wandered its ridges of light, peered into its eternal shadows, and asked questions that may never be fully answered. The moon lingers above as it always has, but perhaps it feels a little different now. Not only a companion of tides and time, but also a keeper of mysteries, mysteries vast enough to carry us gently into rest. There is a certain sweetness in closing the book without finishing the final page. The unanswered lines linger in the air, like a faint melody you hum even after the song has ended. Tonight, let those questions about life, about silence, about our place among the stars become part of that melody. They do not need to be resolved. They only need to accompany you, like soft footsteps leading you deeper into calm. Perhaps you are listening from a city window where the moon hides between buildings, or perhaps from a quiet countryside where its glow rests gently on the fields. Wherever you are, whatever time it may be, remember that countless others in this sleepy little community are also gazing upward, also wondering, also drifting. We are scattered across the world, yet gathered under the same sky, tied together by the shared rhythm of curiosity. If tonight's gentle voyage brought you a sense of peace, you are always welcome to leave a light mark of your presence, a like, a subscription, though never out of duty, only if it feels like placing a candle in the window for fellow wanderers to see. This tiny vessel of stories sails more smoothly each time someone else steps aboard, and I am always grateful for your quiet company. So now, let the questions rest. Let the shadows close softly like curtains around the stage of your thoughts. Feel your breathing slow, your shoulders loosen, the weight of the day sliding away as if carried into the moon's dark craters, stored there in silence. You need not hold on to anything. The universe is vast enough to hold it all for you. May your dreams tonight be gentle, filled not with answers but with possibilities. May you find yourself walking softly across frozen plains of silver, or floating among stars where mystery is not a burden but a gift. And may you wake tomorrow with the same curiosity, the same spark of wonder, ready to look again at the sky and whisper to yourself, the story is still unfolding. Until next time, sleep well, dream deeply, and remember the shadows are not empty. They are waiting, quietly, to sing their song of mystery when you return.